Welcome to Home Learning. The subject's computer science, and today we're going to be looking at binary conversions. The lesson is made up of 3 parts. The first bit, you're going to get an explanation of how binary works, then you're going to answer some questions, and then we're going to look at some exam questions with Mr. Barnes reviewing them so that you can find out the answers. Over to Mr. Holton to explain.
Converting between denary and binary then. So let's just cover the basics. Denary is the number system that you know and love and use probably every single day, whereas binary is the number system that computers are stuck using, which can only have the numbers ones and zeros in it because they use switches. They're stuck on switches computers. And when you're in primary school, you probably had taught something like this. If you had to represent 13 sweeties in a jar, then we've got no hundreds, we've got 110, and we've got 3 units. Okay, so that idea 110 hundreds, that's how that works. The key to understanding binary is it's the same trick. It's exactly the same trick. So we have units, we get the idea of 1 still, except instead of going up in tens and hundreds, we double each time. So we go 1, 2, 4, 8. Okay, and then if I had 13 sweeties in a jar to represent that, then I can do that making up these numbers using each one just once if need be. So 1 8 and 1 4 and then 1 1 is 13. 8 plus 4 plus 1 is 13. So that is how I represent 13 in binary. Okay, and all you need to do really is just keep doubling the number at the top, and you can make any single number that you want. So let's just do a quick conversion. Let's say I've got this binary number here, and it's got 8 numbers in it. Let's say 1, 2, 3, 4, 5, 6, 7, 8. Then all I need to do if I get this binary number is start with 1 on the right hand side, keep doubling all the way. So we've got 8, 16, 32, 64. And 128. You won't be asked to add to figure out any number above 8 bits, as it's called, because it's 8 binary digits. So you only need to go to 128. And then I add up all the numbers that have a 1 underneath them. So that is 128 plus 32 plus 16 plus 8 plus 2. And if I add all these together, then that gives me my answer. That shows me how much this is in denary. So let's do this quickly. Got 10, 10, 6. So you've got 26, 3, 4, 5, 6, 7, 8. And then it's 186 then is what that is. And all I've done is just add up all the numbers that have a 1 underneath them using your sort of basic maths. Okay, so that's how you convert from binary to denary, but you also need to go the other way around. You might need to convert that into denary. So let's have another number then. Let's go for 194. Okay, let's hope that's not too hard a number. I start off just doing exactly the same thing. So I start off with 1, 2, 4, 8, and I keep doubling all the way up to 128. Now, if you've got a small number that you need to worry about, that you need to convert, then this gets quite easy. So if let's say I've got 9, I need to convert the number 9. I can probably figure out in my head, okay, I need an 8 and I need a 1, and then I'm sorted for 9. I can put zeros under everything else. But if you've got a larger number like 194, then you usually need a bit of a method to figure out how to do it. And the method is this. I ask myself, okay, is 128 greater than or equal to 194? I ask myself this. Is 194 greater than or equal to 128? If it is, I put a 1 underneath it and I subtract that number from my total. So right now I've got 194 to start with. I'm going to subtract 128 from it, and that means I'm going to end up with 66. And then I ask myself, okay, is 66 greater than or equal to 64? Yes, it is. So I'm going to put a 1 underneath that. And now I'm going to subtract 64 from my total. And then I'm going to end up with 2. And then I ask myself, okay, is 2 greater than 32? No, so put a 0 underneath it. Is 2 greater than or equal to 16? No. Greater than or equal to 8? No. Greater than or equal to 4? No. Greater than or equal to 2? Yes. So I'm going to put a 1 underneath, and now I'm going to end up with 0, aren't I? I'm going to end up with 0, so I can end up with 0 that out. And there I've converted from my denary number 194 to binary now, so that is 11000010, and that's your method.
So now you should open the Google form task. There's no need to review these answers, so we'll move straight on after you've completed this activity. It should take about 20 minutes. Hopefully those questions went well. You can always retake them if you'd like to. And now we're going to move on to some past paper questions. You've got 10 minutes to complete these. Off you go. We're going to go to Mr. Barnes now, who's going to walk you through those questions, and let's see how you did.
Okay, so now you've had a chance to have a go at these past exam questions. Let's go through them, model them out, and then refer to the mark scheme. So the first question says, convert the binary number 01101001 to denary, showing your working. That's key, showing your working. There's probably going to be some marks for that. So, first thing I always do is write out what I call the binary number line. 128, 64, 32, 16, 8, 4, 2 and 1. And then I write out the binary number underneath. So 0, 1, 1, 0, 1, 0, 0, 1. Okay. Next up, where there's a 1 under it, the number above it, I need to add together. So I need to do 64 plus 32 plus 8 plus 1, which when added together equals 105. And I'm going to write 105 over here and underline it so they know that that is my answer. So let's have a look at the mark scheme. Here, very clearly, I've got 1 mark for showing my working. And I get 1 mark for the correct answer of 105. So 2 marks. Moving on then. Next question is convert the denary number 154 to binary. So I'm going to write out my binary number line again. 128, 64, 32, 16, 8, 4, 2 and 1. And then I'm going to go through the conversion method. So does 128 fit into 134? Well, it does, so I'm going to put a 1 there, and I need to do 154 minus 128, which leaves me with 26. Does 64 fit into 26? No, it doesn't. Does 32 fit into 26? No, it doesn't. Does 16 fit into 26? Well, yeah, it does, so that's a 1, and I need to take 16 from my 26 to leave 10. Does 8 fit into 10? Yes, it does, so that's a 1. I'm going to take away 8 from 10, which gives me 2. Does 4 fit into 2? No, it doesn't. Does 2 fit into 2? Yes, it does, leaving 0. Does 1 fit into 0? No. And there's my answer. One way you can sort of check straight away whether this is correct is then you can add them back together. If a number is even, so 154 is an even number, and you end up with a 1 under the 1, then you've got it wrong, because any even number should always end with a 0 here. Let's have a look at the answer then. So it says here, answer is 1001, 1010. So 1001, it says 1 mark per nibble, so that's the first 4 bits. 1010 for the second 4 bits, and there we have it, 2 marks. Okay, moving on again. Convert the denary number 132 into a binary number, and interestingly here, 8-bit binary number. Okay, so if it was, the answer isn't going to be 7 bits, but if it was and you wrote it as 7 bits, you're not going to get the full marks. So once again, binary number line, 128, 64, 32, 16, 8, 4, 2 and 1. Do 128 into 132 into 128. Yeah, that's fine. So 132 minus 128 equals 4. So that means a 0, 64, a 0 for 32, a 0 for 16, a 0 for 8. 4 into 4 is 1. So that leaves nothing. So the last 2 are 0 as well. Okay, so let's have a little look at my mark scheme. Here it says 1 mark per nibble. So we've got 1, 0, 0, 0 for 1 mark, 0, 1, 0, 0 for the second mark. 2 marks. Okay, last one up then. Convert the binary number into denary. Show your working. So we're going to use the same method as before for the first question. Binary number lines coming out. And then I'm going to write it underneath. Now notice this binary number is only 7 bits. So if I write it starting here, it's going to give me the incorrect answer. So you almost have to write it backwards. So I'm going to write it backwards. 1, 1, 0. 1, 1, 0, 1, because there isn't an 8th bit. So just watch out for that. Then I'm going to do 64 plus 16 plus 8 plus 2 plus 1, because they're all the values that have a 1 underneath. So 64 plus 16 is 80. 8 and 2 is 10, added on is 90, plus the 1 gives me the answer 91. So, one last time then, let's have a look at the mark scheme. Let's push this up a little bit. Okay, so 1 mark per bullet to max 2. So 1 mark for the correct answer, which is great, I've got that right, so 91. Correct working shown, 61 plus 16 plus 8 plus 2 plus 1, there we go, I've got 2 marks. And there we have it, 8 marks in an exam that you should never be dropped.
And that's everything you need to know about binary. We'll see you next time.